So sorry about that for the previous video. So example 3, part D is being cut off. So again, this one is the continuation of calculus, sections 5.4. Okay, so 5.4. Okay, so let's go back to part D. So let's finish this one. So one thing that you want to do is the absolute value of sine of x. So that means it's piecewise functions. So try to separate it out. So this one, it's an integral from 0 to a certain value of sine of x. And then from that certain value, we're going to find out exactly what that is. And then to 3 power 2. And also for the integrand, this one is negative sine x. Indicator, dx. Well, let's just sketch the graph first for the integrand. So the integrand, which is sine of x, it's a sine of x, which is what? Roller coaster. So it's like this. So 0, pi, 2 pi. But this one is stopped at 3 power 2. But one thing that you guys need to watch out, so 3 power 2, and also its absolute value. So that means everything should be right above the x-axis. So that means down underneath the x-axis right here. So we need to flip this dotted curve over the x-axis. So eventually it's going to be like this. Let me just extend that x-axis right here, 2 pi. But the thing is that the integral, lower bound is 0, upper bound is 3 power 2. So that means we need to find the area under the curve from 0 to pi, and then pi to 3 power 2. So that means the first part of this is from 0 to pi, and then the second part of this is from pi to 3 power 2. The reason why this one's negative, since we flipped this one over, so that's why it turns out to be negative. Okay? So now let's integrate it. So integrals of sine of x, so then that would be considered negative cosine of x from 0 to pi. And then this one too, so it's negative cosine of x, but times negative, so positive cosine of x. But don't forget, it's bounded from pi to 3 power 2. And using that f of tc part 1, so negative cosine of pi minus cosine of 0. This one here, cosine of 3 pi over 2 minus cosine of pi. So we want to find out exactly what this is. So cosine of pi is negative 1. Cosine of 0, that's 1. And then cosine of 3 pi over 2, that's 0. Cosine of pi, negative 1, negative, negative, positive. So it looks like eventually this one's going to be 3. So minus 1, negative 2, negative, negative, positive 2, plus 1. So it's 3. So that means the area for this curve right here, so underneath the area, under the curve, so then that would be 2. Over here the area, then that would be 1. So 2 plus 1, which is 3. Okay, so I just want to check one thing real quick, making sure that this one is not stopping. Okay, looks good so far. Okay, so the next one, so find the displacement. So given that v of t, the velocity of the particle, so the time is from 1 to 6 seconds. Okay, so find the displacement. So that means we want to find out the final positions. So for a, so basically just the integrals from 1 to 6, and then v of t, dt. So plugging that v of t, so we do have t squared minus 2t plus, minus 8. Integrated, so basically just a normal integral. So we just integrate, which is t to the power 3 over 3 minus 2t squared over 2 minus 8t. Yes, that's right. And then from 1 to 6. And then the rest of that, so just using the f of tc part 1. So 6 to the 3rd power over 3 minus 6 squared minus 8 times 6. And then this one is just f of b. And then f of a, so plug in 1, so we got 1/3 minus 1 minus 8. And now we just want to evaluate this. So 6 to the power 3. So 6 times 6, 36. Times 6 again, 216 over 3. Reduce, which is 72. Minus 36, minus 48. So this one is for the f of b. And then for the f of a, so 1/3 minus 1, which is negative 2/3. So negative a and 2/3. But minus, so then that's going to be positive. Okay, so 36 minus 48, which is negative 12, plus a and 2/3. So the final position is going to be negative, well, which is correct. So position can be positive or negative. If the particle is being negative, that means it's moving to the left, okay? So the final position would be negative 3 and 1/3. So just check one thing real quick, making sure that this one is right. Integral. So t to the power of 3 over 3 minus 2t squared over 2 minus 18 from 1 to 6. So 6q over 3 minus 6 squared. The 2 got canceled. Minus 8 times 6. And then minus. Okay, so 1 over 3 minus 1 minus 8. So that turns out to be positive. Negative 2/3 and 2/3. So 216 over 3, so 72 minus 36, 36 again, but minus 48. Yeah, so negative. Okay, so now what about for part B? Find the distance traveled by the particle from 1 to 6. So in order to find the distance, so the distance is always considered positive. So that means we want to integrate the velocity with the absolute value of the velocity. Okay, so take a look at that. So integrals of absolute value of v of t. And this one goes all the way from 1 to 6. Okay, so one thing that you want to do, so again, similar to the previous problem, example 3, part D. So probably you want to sketch the graph first. So it's t squared minus 2t minus 8. So we're trying to find the vertex for this. So the vertex for this one would be allocated at t equals negative b over 2a. So then that would be 2 over 2. So it's going to be at 1. Okay? So try to sketch the graph. So the vertex is going to be down here somewhere. So plug in 1. So we got 1 minus 2. Negative 1 minus 8. So it's negative 9. So it's 1 comma negative 9. It's all the way down here. And then the y-intercept, we do have negative 8. So this one is symmetrical. So here's the v of t. Okay, so another thing that got to be careful with this. So it's from 1 to 6. Okay, so 1 to 6. That's the time interval. So 1 right here, so that means you want to flip this one over. So once you flip it over, so this one turns out to be like this. Because that's absolute value. So it's going to be 1 comma 9 then. Okay, so just flip this one all the way through. Okay, so like this. Okay, so now let's find out the sharp turn position here. So the way to find it, so we can just set that the v of t equals 0. So set v of t equals 0. And then we factor it. So t minus 4. And then t plus 2. So we got t equals 4, t equals negative 2. That means this position right here, that's 4. So once you separate it out, so we do have integral from 1 to 4. Since we flip this one over, so that means it's going to be negative quantity of t squared minus 2t minus 8 for the first half of this. So the second half of this would be the integral from 4 to 6. Okay, from 4 to 6. And then that'll be t squared minus 2t minus 8. Well, this one we don't flip it, so that's why we just keep the original v of t. dt. Okay, so now let's integrate it. Okay, so I need more space, so let's just do it right here. Okay, so the integrals Okay, so from 1 to 4. Okay, so this one turns out to be negative t to the power of 3 over 3. Negative, negative, so positive, so 2t squared over 2. Okay, so this one's positive. And then negative, negative, positive, so plus 8t. And then it goes all the way from 1 to 4. And then the second integral. So integrals of t squared, so t to the power of 3 over 3. Minus 2t squared over 2, so the 2 got cancelled eventually. Minus 8t is quite similar. But you guys see that the sign is completely different. So this one's negative, positive, positive, negative, positive, negative. Because that, we just flipped that over the x-axis, the reflection. So this one, it goes all the way from 4 to 6. Okay? So now, using that f of tc part 2. So negative 4 to the power of 3 over 3 plus 4 squared plus 8 times 4. Got to be careful and slowly doing things like this. Okay, so, and then minus, okay, so minus, so negative 1 over 3 plus 1 squared. So let's put it in parentheses for the whole quantity because you subtract the whole quantity. Minus, okay, so plus 1 squared and then plus 8 times 1, so plus 8. So we just take care of the first integral. And now the second integral, so we do have 6 to the power of 3 over 3 minus 6 squared minus 8 times 6. Okay, so let's just separate it out first. Minus 4 to the power of 3 over 3 minus 4 squared minus 8 times 4. Okay, so one thing at a time. So let's just find out what this first, and then we'll just combine it with the rest of this. Okay, so this one is a separation, so eventually we can combine them all together. So negative 64 over 3 plus 16 plus 32 minus this whole quantity, so negative 1/3 plus 1, 2/3. Okay, so a and 2/3. 8 times 3, 24, plus 2, so 26 over 3. So minus 26 over 3. So let's find out what this is first. So we do have negative 40 over 3. Combine the fractions together. Negative 40, hold on a second. It's actually negative 38 over 3. Once you combine them, because you're just doing subtraction right here. And then 16 plus 32, we do have 48. Okay, so what about this part right here? So bring it down. So 6 to the power of 3. Okay, so that would be considered 216 over 3. 216 over 3, 72. Minus 36 minus 48. Then subtract this whole quantity. So 4 to the power of 3. 64 over 3 minus 16 minus 32. Again, this one eventually we're going to combine this all together. Plus. So 36 minus 48, negative 16. And then 64 over 3 minus 48. So it looks like we do have 96 right here, negative, negative, positive. So 96 minus 16, then that'll be 80. And then negative 38 over 3 plus 64 over 3. Then that would be positive 26 over 3 plus 80. So that's a lot of arithmetic right here, a lot of computation stuff. Okay, again, this one got canceled, this one got canceled, so we left with this one. No, this one would be 96 minus 16, then that would be 80. And then combine this together, 26 over 3 plus 80. So 26 over 3 plus common denominator is 3, so 240. So combine them, so then that'll be 66 over 3. So that'll be the total distance. So again, finding the total distance is a whole lot more challenging compared to finding the displacement. Because that, you have to sketch the graph, find out the position that you need to break it apart. And also you want to integrate both part of the integrals. And then you want to do all the arithmetics together. And then combine them eventually. Okay, so now let's figure out the last one. Okay, let's see what that is. So for example 5, so given that a of t equals 2t plus 3, so v of 0, so it's given already, it's negative 4. And then the time, it goes all the way from 0 to 3. Okay, so 0 to 3. So we need to find the velocity at time t equals, at time t. So that means we need to integrate the acceleration. So once we integrate acceleration, that one is just an indefinite integral. So that means we end up with the constant c. But how do we figure out the value of the constant c? Okay, so now take a look at that. So once you need to find the velocity of the particle, so you want to integrate that a of t, dt. So 2t plus 3 times dt. So we got 2t squared over 2 plus 3t. Plus constant c. So one thing that we notice, so v of 0 is negative 4, so that means we need to plug in a number back to the velocity. So negative 4 equals 2 times, well, 0 squared plus 3 times 0 plus c. So that means the value of c is negative 4. So for v of t, the one that we found, reduce, so t squared plus 3t minus 4. That's the velocity for A. And now, finding the distance from 0 to 3. Again, in order to find the distance, so that means you need to find out the position that is considered the sharp turn right there, because we need to break it apart. Okay? So now, let me just erase this. So for v of t, the one that we found, so let's just sketch the graph for that one. It's a parabola. Okay, so this one, let's find out the vertex. So the vertex for this one would be considered negative b over 2a for t. So negative 3 over 2 times 1, so it's negative 3 half for the vertex. Or basically we can just do it like this, we can factor it. So t minus 1 and then t plus 4. So sketching the graph. So for the 0, we have 1 and negative 4. Okay, so let's just start it over here. So 1, 2, 3, 4, negative 4. Here's 1. And then the vertex, it's allocated in negative 3 half.